Okay, in this video we're going to continue our series about factoring trinomials and just recognizing patterns, right? Because that's really what we do. One of the great skills from learning how to factor is to see what kind of patterns that occur that are in numbers. We're going to do trinomials that we call perfect square trinomials. Let's take a quick look at three different examples of that, okay? Now here's probably the most basic example right here, x squared plus 2x plus 1. Now, again, factoring means that I'm going to try to find the products, or what times what multiplies to equal this trinomial, okay? Now, the way you do that is to examine the first term in the trinomial and the last term in the trinomial. And the question you ask is, are they perfect squares? Are the terms perfect squares? Because if they are, you can continue to the second step. Now, in this case, it looks like x squared and 1 are both perfect squares, doesn't it? So x times x and 1 times 1. If they are, then set this up like this. Do two different binomials, space for two different binomials, and just put the x and the x here, and then the 1 and the 1 here. Now again, you have to ask yourself, what times what gives you 1? And my two possibilities are plus 1 times plus 1 gives me plus 1, or negative 1 times negative 1 gives me plus 1. All right, so I have to decide between the pluses and the minuses. The way you decide that is to look at the middle term. All right, they have to add up 2 plus 2. So it looks like my choice then is plus 1 and plus 1, because 1 plus 1 is equal to 2. All right. Now the way I check that is something I call the smiley face method. And the smiley face method just kind of looks like this. Just connect this first one with this last term, and then the two inside terms. And it looks like you got a little face there. There's a nose, there's a face, a couple of ears. Anyway, so 1 times x is x, 1 times x is x. You add them up, you get positive 2x, and if that matches here, then you have a perfect square trinomial, and there it is. Okay, let's take that exact same method and look at this second example. All right, so here we go. Is this term a perfect square? It is. Is that term a perfect square? Yes, it is. So let's go ahead and do space for binomials. Let's put the two squares here, 2x, 2x, 1 and 1. Again, it looks like it's plus plus, so let's just put the plus plus here because, again, there's no other possibility there. Let's do our smiley face. 2x times 1 is 2x. 1 times 2x, again, is a positive 2x, adds up to positive 4x. They match. Here's my factored form. Now, I'm going to try a little bit more challenging example. You know, my students know that I am very fond of saying that, you know, difficult looking problems really are just a bunch of simple ones that they have stacked together. So let's see if we can just find the simple problems that are stacked up in here using these exact same questions. Is 16 a perfect square? Yes, it's 4. X squared? Yes, x. X times x rather, and y, same thing, y times y. Is z to the 4th a perfect square? Again, the answer is yes, because z squared times z squared is z to the 4th, right? You just add the exponents. So it looks like we're on our way to seeing whether this is a perfect square trinomial. So let's just do two binomial spaces. Let's put the factors in here. And then z squared, z squared. Now, let's pay attention to our signs. They have to multiply to get plus, but they have to add up to negative. And I know that if I have a minus and a minus times a minus gives me a plus, and then when you add two minuses, you'll get a minus as well. Let's check to see if this is correct by looking at the smiley faced 4xy z negative z squared is negative 4xyz squared. Negative z squared times 4xy again is negative 4xy z squared. Add that up, you get negative 8xy z squared. Sure enough, there's the factored form. Okay, so you can recognize perfect square trinomials by again asking the question, is the first term and the last term perfect squares? If they are, check and see if the middle term adds up after you've done the smiley face method. Okay, hope that was helpful.